Hi, I'm Barry Briggs at Directions on Microsoft, the world's leading independent analysis firm covering Microsoft. And I do believe that the company has a clever, visionary, but frankly very risky strategy for AI, and that's our topic for today. I'm going to synthesize what they've been saying and present my interpretations and my opinions about what they're doing and where they're headed. We're going to walk through it top to bottom, and I'll even do some very brief demos along the way. Now, we'll only be giving you a flavor of the various apps and tools to illustrate our points about this strategy. No worries, however. If you want deeper analyses, check out our site at directionsonmicrosoft.com. Let's dive in. Should be fun. If you've been paying attention to Microsoft, you can't help but notice that Satya Nadella, the firm's CEO, has been everywhere of late. The US, Europe, India, Davos, evangelizing the company's vision. It's almost unprecedented for a CEO of a Fortune 10 firm jet-setting across the world like this to explain this new direction. And we've seen a blizzard of new products, new services, copilots and tools and models and agents and data warehouses, analytics. Is Microsoft just throwing things against the wall to see what sticks? Or is there a strategy? And if so, will it work? Should companies bet on it? What could go wrong? And ultimately, is Microsoft itself betting the company on its new strategy, making Satya the philosopher king of tech? Let's take a look. I'm suggesting that there is indeed a case to be made that Microsoft's bets will pay off if they've invested correctly and if the market is ready for all this innovation. But, as with all such bets, well, there are risks, speed bumps, and things that could just plain go wrong. Can Microsoft surmount them? Let's see. Well, we should have an agenda slide, and here's ours. We'll first start with the big picture, what I'm going to call Microsoft's AI native vision for software. And what I mean by that is a new stack for applications and services. That's right, a new stack. And if you believe Microsoft, the change is tectonic. It is a paradigm shift. Then we'll look at each of the layers in detail, user interfaces, models, data, hardware, tools, and we'll see how Microsoft is investing at each layer to give customers, eventually, a totally cohesive environment for AI native applications. Finally, we'll look into the future. What's on the horizon for Microsoft? What could help them? What could go wrong? Where are those speed bumps that we talked about? And don't worry, among those risks or major opportunities, we'll discuss the emergence of new AI initiatives, both here in the US, Stargate, and the talk of the day, China's DeepSeek. So hold on. Let's start with the new stack. Now, this is Microsoft's vision. You may or may not agree, but this is how they think about it. So at the top, Copilots. They're the user interface, the out-of-the-box usable technologies that an end user can start typing in right away. A very loose analogy, which we'll come back to, is that Copilots are kind of like Excel. You can launch it and start typing right away. Now, models are the engines that enable Copilots, but just like Windows and .NET enable Excel and other applications, so too do models provide the underpinnings for your custom AI native applications. We all know what these are, GPT this and that, Llama, DeepSeek, and so on. Models are also the basis for AI agents, that is, AI-powered software that can do things on your behalf, maybe even autonomously. Data, of course, is the fuel for models. Models consume data. They eat data omnivorously. And Microsoft's goal here is to provide data management tools and services that can best serve up data to AI, but as we'll see, they face some pretty stiff competition here. And finally, custom hardware is increasingly essential for AI. Obviously, the market leader here is NVIDIA, but we all know they're very expensive and in short supply. Is it possible for Microsoft to use other vendors or to build their own hardware? The answer is yes, but arguably they are behind, maybe even way behind their competition. So that's the application stack. But let's not forget that Microsoft is at heart a developer's company, so for each layer of the stack, there's a complementary tool or set of tools targeting specific personas, the so-called citizen developer, the professional developer, and the data scientist. All this means that there's an entirely new way of thinking about what exactly is an application and how it's constructed. Now, in the early 2000s, we enthusiastically talked about the so-called three-tier model for apps, consisting of UI, that's HTML and JavaScript and CSS, and business logic, C# or Java, and a relational transactional database like SQL Server or Oracle. And some of us actually built such things, but they were kind of hard to build because they required 3 teams with 3 separate skill sets. Now, in his public speeches, Satya appears to be asserting that new applications will have a steadily decreasing amount of procedural code, and that more and more of the application will be based on AI agents, that is, AI-based modules that can take actions like sending an email or updating a customer record on your behalf. And you interact with such applications, how? Via conversational interface, that is, a chat or a Copilot. Now, the amount of procedural logic and relational data decreases, one might say, asymptotically, but never goes to zero, because organizations will always need deterministic data, and don't forget, at their core, LLMs are probabilistic. We'll talk more about that later. Bottom line is, you don't want to bet your regulatory filing on an LLM. But the agents that run your business can use far more than relational data. They can tap into everything, tweets and social media and emails and audio and video and so on, giving far more context to the application and its agents than ever before possible, and thus vastly improving decision making. You buy that? You don't have to, but at the end of the day, that is ultimately what I believe Microsoft and Satya are evangelizing. Now, before you decide for yourself, you need to understand and evaluate how Microsoft is both thinking and investing to make all of this happen. And that's what we'll talk about in the next section. Let's start at the top. The user interface layer, which we all know by now, is branded as Copilot. First, we'll begin with some very loose analogies. Satya likes to compare copilots to Excel. What does he mean by that? Basically, the idea is when you start it up, you immediately get a UI that you as an end user can start using. Of course, underneath the UI, there's a ton of code supporting and driving that UI, just as there is in Excel. So if you follow Satya's analogy, Excel and Word presents you with a canvas to start writing on right out of the box, but of course there's tons of code underneath. And for Word and Excel, those are DLLs and libraries and so on, but for Copilot there are LLMs and models and training data and so on. Microsoft has adapted the Copilots to each of their apps, so there are obviously different capabilities in different Office applications, and we'll take a look at those in just a second. The point of this is, ironically enough, this is more than New Clippy, which some of you may remember from Office 97. It died shortly thereafter. Copilot really is much more than Clippy, and in some ways is the fulfillment of Clippy's original ambition. So now Copilots are appearing everywhere in Microsoft's application portfolio, and we've got a convenient list which we keep up to date on the directions on Microsoft's site. It's yours for free. There's the URL in the bottom right. But all of this begs the question, and we talked about this a few slides ago. Are these conversational UIs becoming the default UI for all applications? Well, it's too early to say, and Microsoft may have to pry 3-layer deep menus from our cold, dead hands. But if you read the tea leaves, it makes you think. By the way, if you want to try something fun, ask Word to write an essay about yourself. Results can be surprising. And I'll also add that while Copilots do present a nice conversational UI, they may not be as intuitive as Microsoft thought. See, I get these emails every month from Microsoft with tips on how to use Copilot, which maybe belies the notion that they're incredibly intuitive. Anyway, Copilots have been in general availability for less than a year. It's clear now that the early value came from easy out-of-the-box features like summarizing Teams meetings and long articles and coding, which we will talk about in a second. The big value, I think, is coming from connecting to local enterprise data. Let's see how that works. So just to give you a brief idea of what this looks like, this is the Copilot for Microsoft Word. This is its current UI. It does change from time to time. We'll ask it to write a quick article about the benefits of Copilot. It'll think about it for a second, and then it'll start writing an article on our behalf, and it's pretty good. And here we are with actually something that's pretty useful, which is we're going to create a pivot table from these cells. And this is something that I don't know about you, but every time I have to create a pivot table, I have to go to the Microsoft help pages to re-understand how to do that. So it's thinking about it, it's analyzing, as it says, and it's created a pivot table for us. As it finishes up, we can, here we are. We can now add it to a new sheet, and there is our pivot table. Pretty cool. So as we said, the value of Copilot, real value, Microsoft would say, lies when it can connect to your local organizational data, like documents in your SharePoint libraries. So here, our user is asking to write a contract similar to the one they've already written. That means that Copilot can reach out to SharePoint, find the library where the old contract is stored, retrieve it, and write a new one similar to it, changing the names and maybe a few terms. So it augments the generation of new content by retrieving data, hence RAG. And we'll have a lot more to say about RAG apps as we continue our tour of Microsoft's strategy. An important point, however, is that your data, the contract in this case, is not used to train a public LLM. That is, it's not exposed to the rest of the world. It's kept private to your organization. That's not to say there aren't any issues. We'll talk about those in just a second. Now, the same mechanism, of course, can be used to access data not just in Microsoft 365, but in other sources as well. For example, SAP. Same idea. Now, the very first Copilot was GitHub Copilot, and it leverages the vast amount of code in GitHub to help coders code. There's now a free version, but there are paid versions with many more features. We've written lots of reports about it, and Microsoft is heavily investing in it, probably because there's a lot of competition from both other vendors like AWS and the open source community. GitHub's probably the furthest along, however, and it can help you not just write code, but write according to your organizational standards, follow enterprise patterns, find problem areas in your code, and explain your code. It's kind of amazing, actually. And this quote from the bottom from a friend of mine may signal that we've hit a tipping point. GitHub was originally positioned as an assistant to the coder, but he feels now that he's assisting Copilot, which is kind of interesting. And here we are in GitHub. This is some code that I'm using in one of my projects. It's an open source code, and I'm just wondering how the heck it works. So I can open GitHub Copilot and ask it to please summarize this code. And there it goes. It tells us what it does. Now there are issues. Let's say HR has a SharePoint site, and one HR professional uploads some salary data to a document on that site. Even if nobody else knows about that document, Copilot can find it right away. So Copilot can access that Microsoft graph. It can see all the SharePoint and Word documents and PowerPoints and so forth. And with the pre-configured, with those connectors we talked about a few minutes ago, it can access other applications like SAP, all of which means that we have to protect this data from Copilot. We have to make sure that we've implemented the right ACLs and permissions and encryption and sensitivity labels and e-discovery so that any given individual can only see content that he or she is authorized to see. And we'll talk about the tool that we use to do that called Microsoft Purview in a moment, but suffice it to say for now, most of those key features that we need in enterprises are only available with E5, the most expensive tier. Okay, wrapping up our quick tour of Copilot. We've seen that it is a brand and it's a technology and maybe even the new user interface for applications. Well, we'll see. The reason why may be that it's a zero barrier for entry. Just load the application and ask it to do something. In the early days of Copilot, there was a lot of FOMO, but we're now finding that that $30 per user per month cost may be negotiable with Microsoft, suggesting there's some price resistance. And the reason for that may be that the ROI is notoriously difficult to measure. It's hard to say if you're writing 20% or 30% more contracts today than you were the day before you got Copilot. Microsoft is investing in tools to help customers find the ROI, and we've written a bunch of reports about it, and the directions on Microsoft's site. Last thing I'll say is that Microsoft is revving the Copilot underpinnings, the models, from time to time. However, risks still exist. As we talked about, it can have very fast and even sudden unauthorized access to data, so it's important to protect your data. It can plagiarize, it can hallucinate, and we'll talk about the regulatory aspects a little bit later, but they are significant and well worth paying attention to. So let's talk about models, that is language models, the engines of AI applications like Copilots, but also for your own custom AI apps. Let's dive in. Now, before we begin, it's important to know that AI has existed long before ChatGPT and long before large language models. And old AI technologies, like you see in the blue here, focused on how to classify things. And what you see, those little circles, those are neural networks. And they could analyze a picture like that picture of my dog, and after having been trained with, say, 10,000 labeled pictures of dogs and cats, it could usually pretty accurately figure out that this was, in fact, a dog. Or on the right-hand side, this is, in fact, a happy customer that tweeted about our restaurant. But then generative AI came along. And with generative AI, we generate new content, wholly new content, using these pre-trained models. So we can generate a picture from text, show me 3 dogs dancing on the moon, which was the subject of a blog post I wrote some time ago on the Directions website, or where does the name Dolly come from? It's really pretty clear now that models for generative AI that can generate new content like this change the world. And we'll remember November 30th, 2022 as the day that happened. Really was the beginning of an era. The academic paper on the right actually was the basis for all this in a sense. It recognized that to understand language, you really need to understand, that is, pay attention to words in their context. And that's a very simple explanation of a very complex concept. In any event, Microsoft soon after licensed exclusively OpenAI's models and introduced them in Copilot and made them available for developers in Azure's OpenAI service. Key takeaway from all this, models are the core component that run generative AI applications, including chatbots and copilots and summarizers and agents. Let's just digress for a second and talk about why does AI require these enormous investments we keep hearing about in data centers and GPUs? And the answer is that training a large language model is incredibly compute intensive. And there's a ton of math. It's pretty straightforward math, matrix multiplication and exponentiation, but it's done at extreme scale and running extreme parallelism. Now, the interesting thing about this is that it's pretty much what the same types of calculations that a graphics processing unit does when you're playing a video game and it's rotating an image or killing an alien. And NVIDIA discovered this, that they were perfectly positioned to do not only just graphics, but also AI. And that's why I say NVIDIA was the luckiest company on earth, and that has generated a pretty immense market cap. Now, training LLMs is pretty compute intensive. Inferencing, which is solving problems on a trained model, requires much less compute. Why is all this so hard? Well, here's a simple way of imagining this, and I promise you this is the only math in this deck. If you remember from high school, the slope of a line, y equals mx plus b, well, there are 2 constants in that equation, m and b. GPT-3 is solving equations with 175 billion constants. These are called weights, by the way, or parameters. DeepSeek R1 is the big one, is the recently announced one, is 671 billion parameters or weights. That's why we need tens of thousands of servers. That's why we need the cloud to do training. Amazingly, in the short time since November 2022, these models have become commoditized. We have these general purpose large language models, foundational models such as GPT-4o and Llama 3b, open source from Meta, Google's Gemini. We also have targeted low footprint models, which we call SLMs, or small language models, because they're trained on much fewer parameters than the large ones. These can be deployed for special workloads, for on-premises cases at the edge. Microsoft's own 5.3 and 5.4 are examples. And we're also starting to see the emergence of next generation models, such as OpenAI's O1 and their forthcoming O3, which are capable of planning and reasoning, which we've seen actually in DeepSeek that just came out very recently. But to give you an idea of why I say these are commoditized, there's a public model repository called Hugging Face, and it sports currently over 1 million freely usable, freely downloadable models. Azure itself has well over 1,800 of them that developers can choose from. Here's a quick screenshot. We'll take a little bit closer look at this later, but these are the some of the models that Microsoft makes available for developers to use. You can also do this on your desktop now. There's a vibrant social media enthusiast community for this application called Ollama, which allows you to download a slew of LLMs, assuming you have room on your machine to run them. And you can, from the command line, in this case I'm running 5.3 and I'm asking why is the sky orange at sunset, and there's all sorts of YouTube videos that you can watch to learn all the tips and tricks of running LLMs locally on your desktop, and it's kind of fun. Okay, let's talk about agents. Agents are, of course, models that do things for you. They take actions on your behalf. They're more than a glorified search. They actually take actions on humans' behalf, potentially reducing your work, potentially reducing the workforce as well. And obviously, there's a lot of hype about this. Let's take a look at it. The canonical example is, of course, customer service. The user calls customer support with a question, and instead of an IVR answering it with those terrible voice trees, we get a friendly LLM that can take down the customer's information, that can record the customer's problem in detail and get all the context and nuance and so forth, can look up information in knowledge repositories throughout the enterprise, can potentially route to another agent if either human or automated if it can't answer, maybe even invokes, let's say reverse logistics, return the product process, and so on and so on. If this sounds like a lot like an improved IVR, well, it definitely is. If it sounds like business process management plus, it kind of is, because if we think about what these scenarios really are, there's an event, in this case the customer calling, there's some sort of processing, and then some sort of resolution to that event. In the old days, that processing was a human, for example, or an IVR, or it was some code, or it was a rules engine, and now we're replacing all that with an LLM. And if this sounds a lot like what an application, like a customer service application, or CRM application, well, remember that slide that we showed up at the beginning. This is, in fact, a harbinger, perhaps, of the new application model, the new AI native application model. And moreover, the latest generation models can plan and reason, as we said. So maybe in some point in the future, they can even create their own ad hoc business processes on the fly, which is kind of an interesting, exciting, maybe even scary possibility. Now, of course, any discussion of models wouldn't be complete without a discussion of safety and bias. And what we've learned is that these LLMs are really only as good as the data they're trained on. And if the underlying data is biased, even if unintentionally, well, that's what the results are going to be as well. So if you look on the right-hand side, The Washington Post did a fascinating study where it just simply asked various LLMs to draw a pretty woman. And in this particular case, about 9 out of 10 were light-skinned. And that's kind of amusing, but with AI robots that scan resumes or filter college applications and so on, the thing is LLMs are often, and the training for LLMs are often based on what? Past successful candidates, and that can introduce bias. So Microsoft, to their credit, has pioneered principles, and they actually have quite a number of tools behind their Responsible AI initiative. You can click on the link and you can go to their Responsible AI page. They have a whole bunch of tools to help measure how well grounded the AIs are, the models are, how if they generate harmful content and so forth. And we know that Microsoft and OpenAI use these. To what extent, like other open source LLMs do, we can't really always say for sure. Lastly, I hear this question from time to time: is Microsoft competing with OpenAI? And I don't think so. First of all, we'll say that Microsoft has been investing in AI for a very long time. It was actually one of the very first projects or initiatives that Microsoft Research became involved with back in the early 90s. We'll say that, we can say that Microsoft has invested a lot in OpenAI. The specifics, they haven't released, and they are closely held. It's believed to be about $13 billion or so over multiple rounds, multiple tranches. What the form of that investment has not been disclosed, whether it's cash, Azure credits, or what have you. Microsoft hasn't had any hesitation in making their own models. They've introduced the 5.3 and 5.4 models, a couple others that have not gotten as much notoriety. But the point is here that we believe, and I think Microsoft believes as well, that there's decreasing differentiated IP in the models themselves. The models are only important as components of larger applications. So Microsoft has a great partner in OpenAI. That lets them focus more and more on the uses and applications and the workloads that AI applications can address. All that having been said, it is possible that DeepSeek, which does a lot of the same things, at least allegedly, that OpenAI can do, if it all turns out to be true, DeepSeek may change Microsoft's long-term view of the value of OpenAI. We're not sure. Summary points about models. This is an arbitrary segmentation. One way to look at it, there are premium foundation models like GPT-4 and 4.0 and 0.1 and forthcoming 0.3 that have new features and are evolving in new ways beyond simple content retrieval. There are a set of commodity models that you can use in Azure, like Llama 3 and DeepSeek for that matter. And some of those can be locally downloaded using Llama on PCs or Macs, and you can use them to build custom desktop applications that are AI enabled. We talked about how models can be customized before when we were talking about Copilot. We can customize them using either RAG or another technique called fine-tuning, and we'll talk more about that in a minute when we talk about AI Foundry. In both cases, Azure and OpenAI both guarantee that your private enterprise data is not exposed to public models. We don't think that the commoditization of models is likely a threat to Microsoft's strategy because Microsoft is focused in a different area. Microsoft wants to be the AI solutions provider and the tool set for AI applications. And finally, models are evolving into agents which can run autonomously and execute actions. Will they replace code over time, as we posited early on in this presentation? Will they run the business logic? Will they actually become applications? Interesting thought. Let's keep going. Now, as we said before, data is the fuel for AI. Let's take a look at Microsoft's many-faceted approach to serving it up and the critical importance of data governance in an AI world. Now, here is a slide I adapted from one of Satya's, where he talks about the data cloud and all the different sources in the Microsoft ecosystem of data that can be served up to AI. Used to be known as the Intelligent Data Platform. And in the limit, all enterprise data, as we've talked about, is food or fuel or fodder for the LLMs. Interestingly enough, in the middle, Satya made the comment that ChatGPT is Cosmos DB's largest user, Cosmos DB being Microsoft's premier NoSQL database. But when we look at this, particularly at the green box on the right, Fabric, what could possibly go wrong? Where is the potential speed bump in this picture? And the answer is that there's white-hot competition in this space. Big data, warehouses, and lakehouses, and Delta Lake, and so on. Meet AI, we're seeing the battle of the data titans. Now, it's easy to say that Microsoft wins no matter what, because all of these can be hosted on Azure. Snowflake and Databricks can both be hosted on AWS as well, or Google. They are differentiated, though. Snowflake really made its name because they have a very advanced core technology. They have a nice separation of compute and data. They're independently scalable, which helps them adapt to a lot of different and diversified use cases and workloads. Databricks may have the most advanced AI implementation. They have a tool set called Mosaic AI. And they also have a very well thought out data governance capability called Unity. We'll talk about why we think it might be a walled garden in just a second. Now, those two are differentiated as they're private, as they're separate from Microsoft, from the Microsoft offering, which is called Fabric. Unsurprisingly, it has the best integration with the Microsoft ecosystem. That is to say, with SQL Server, the relational database, Power BI, the visualization and BI tool, Copilot even, and it's deeply integrated into the Microsoft Purview compliance and data governance solution. We'll talk about that in the next few slides, but just want to emphasize that while the Databricks Unity catalog can govern all of the data that Databricks knows about and governs, manages, Purview is actually enterprise-wide, so it covers not just Fabric, but all of the Microsoft data assets. Because in an AI-centric world, as we talked about with Copilot, data governance and controls on data are critically important. What could go wrong? Well, confidential information could be leaked to a public LLM, like that's what happened to Samsung in the early days of ChatGPT, or employees or anybody could access unauthorized data like that personnel or salary information that HR person put up on SharePoint inadvertently. We have to know that AI can return invalid or out of date, incorrect data. There can be privacy violations that you don't know about, and so on, and so on, and so on. And because LLMs can scrape data quickly and respond quickly to user prompts, you need to protect this data. This isn't a new concern, but it's made much more urgent by the power of AI to find data anywhere, anytime, which led to this wonderful quote that I heard from a Microsoft employee, again, in the early days of Copilot. Don't give Copilot to your admin because the admins have access to everything. So what is Microsoft doing about that? Well, they have this wonderful tool called Microsoft Purview, which is an enterprise-wide compliance and data governance service. I think of it as the unsung hero of the Microsoft portfolio. It's something that Microsoft has been investing in extensively over the past few years, somewhat independently of Copilot and AI, because customers need this anyway. In my opinion, it's years ahead of its competitors. It has a broad spectrum of capabilities. I won't go into them all, but you can take a look at just some of the capabilities listed down here below. E-discovery, sensitivity labeling, putting labels on documents and that sort of thing. Regulation-specific reporting, how secure is my data estate from GDPR or from banking laws of a particular country and so forth. It also has specific tools for monitoring the usage of AI. How many people are using Copilot? How many people are using third-party AI tools like Perplexity or Claude? Some of the premium versions of Purview actually use AI in and of themselves to expedite manual tasks. So, For example, something like called trainable classifiers to look through all your content and say, oh, this looks like a contract. I should mark this sensitive, do that automatically. I would say that tools, Purview itself, or tools like Purview, in the age of AI are critically important for organizations to use. They must get their data estates in order. However, it can be a heavy lift. There's a lot of data to control. Making sure you've got it all can be a big task. So Purview compliance and data governance, it is a feature-rich service. It is essential. It's not necessarily complete. There are some screenshots of some of its capabilities like data lineage and reporting on the usage of sensitivity labels, and you report on where some of those documents potentially were leaked or exfiltrated in an unauthorized fashion. It's a new capability called Data Security Posture Management for AI. It tells you how ready you are for enterprise-wide AI deployment. And overall, Purview's ambition is to be enterprise-wide, to be your overall compliance and data governance capability for the entire data estate. However, you should know there's still limited support for third-party applications for data sources that in other clouds, and we know that almost all companies are multi-cloud these days. They are getting better. They're constantly adding new sources and connectors. But it's something you should be aware of and something to take a look at when you're getting ready to deploy. So some summary notes on data. Microsoft's ambitions are huge. They're always huge, actually. That's just Microsoft, but they will take time to complete. In the meantime, customers are faced with a familiar best of breed versus the best compatibility dilemma. To be honest, Fabric is still playing a little bit of catch up with Snowflake and Databricks. Snowflake and Databricks can both be hosted in Azure. It looks to us like Databricks is more favored than the others, but that could change over time. We should note that data governance requires both technology, Purview, which we talked about moments ago, as well as organizational transformation. Purview is an integral part of the solution, but you have to train the people to use the sensitivity labels, to respect them. You have to monitor their usage. You have to track the alerts that you get when something potentially goes wrong. For example, when data is copied to a place it shouldn't be or accessed by someone who shouldn't. And that's why we say that a well-architected, well-governed data estate will probably take the organizations years to create and fully implement. And lastly, I'm going to leave you with a thought experiment. Let's just say in the future, 3, 4, 5, 10 years from now, some enterprise LLM can access everything, and we have a wonderfully well-governed data estate. And you can ask it any question about any data source anywhere. You have to ask why you actually need a data warehouse. Right now, we're just asking. So as we've said throughout the course of this presentation, Microsoft is nothing if not a developer company. Let's take a look at some of their offerings. Microsoft has always been a developer tools company. AI is no exception. And what's interesting is Microsoft has always used this concept called personas, that is to say, descriptions of target users to understand how to focus the development of their products. And in this case, Microsoft has really focused on 3 personas. The citizen developer, the low-code or no-code developer, who uses a tool called Copilot Studio and may use a set of models, pre-built models called AI Builder. The solution or professional developer, category I fall under, use a tool called AI Foundry with a set of associated AI services. And data scientists, who use Azure ML Studio. Let's take a look at each of those, starting with Copilot Studio. Now here we are in Copilot Studio, which, as we said before, is targeted at the citizen developer, the non-professional, non-coding developer. Now, by way of background, Copilot Studio has been through a little bit of an evolution. It came originally from Tower Virtual Agents, which allowed us to create structured conversations like bots, and then changed into a tool which could help you build your own Copilot. And now it seems to be about building your own agents as things that can do things on your behalf. And interestingly, It has its own Copilot-like interface. I can actually describe with everyday words what my agent should do. So let's say I would like you to design a customer service agent. And it will go through a whole process of understanding first what a customer service agent actually is. It will do some work over here and give me an explanation, and then I can go and configure it. Now, as we mentioned, the positioning of Copilot Studio appears to be evolving. There's also a set of pre-built libraries called AI Builder, and it's originally targeted at Power Apps and Power Automate suite of applications. Doesn't appear to be quite reconciled yet with Copilot Studio, but it's likely. Now, before we get into the tools for professional developers, let's think about what do professional developers need from their tool set. And the first thing is they customize models, right? We talked about RAG in the beginning of the presentation. It uses external data like SharePoint or SAP or your own applications to augment the model. This is what Copilot uses. You as a developer can use it too. And this is most useful for rapidly changing data, like a newsfeed. We're constantly updating the data. External data gets frequent updates. For example, directions on Microsoft Chatbot. And if you're asking, gee, are we working on directions on Microsoft Chatbot? I'll simply say, that's an interesting idea. There's another approach, which is called fine-tuning. And in fine-tuning, you actually adjust the weights of the LLM, the model, at runtime. This is not something you do every day. It's a more complex task. In this case, the LLM actually reaches out during inferencing to a private set of weights that you create and adjusts its responses accordingly. And it's useful for slowly changing data, like legal precedents, for example, historical data, and so on. So let's take a look at AI Foundry. This is the primary tool for professional developers building AI native applications, and it allows solution developers to build these RAGs or fine-tune LLM applications. It has a wonderful playground to allow developers like me to play with different LLMs, play with different system prompts, connect to enterprise data sets, see which ones deliver the best results, and then it allows me to actually push a button and deploy a simple application. And I've been very impressed with it because even though it's really quite new, it's actually quite well thought out. It's gone through a very rapid evolution, and it continues to receive pretty rapid and pretty substantial investment. Now I'm in Azure AI Foundry now, which allows professional developers like me to build AI-centric applications. And I'm very impressed, as I mentioned, with this application. Here is, we looked at this screenshot of this before. Here are the various models that are available to me. One of the things I like to go to is the playgrounds. And the playgrounds allow me to test things. So here I'm going to say, I'm going to create a new system prompt. And instead of saying that, we're going to tell it what kind of assistant it wants to be. We'll say, update this. So it's an experienced objective technology analyst, but you don't mind a bit of snark every now and then. But we're not done yet. Let's actually add some data. And I have some data available to me in a blob. And so I'll add that data. And now I actually have a RAG app. Tell me about Microsoft Purview, which is their privacy management service. Let's see what they say. And this is just a playground, so we're trying it out. And you'll see it gave me an answer of what Microsoft Purview is based on some data that I gave it. And you'll notice the little things down here is the little gizmos here. These are citations, and we can actually go to the citation. We've actually built a RAG app just like that. And all we have to do is go up here to the deploy, and we can actually deploy a real application. Pretty cool. That just touches the very tip of the iceberg that is ai.azure.com, that is to say the AI Foundry, but it's pretty cool. Having looked at that, there's a whole set of supporting services that developers can use in their applications. what's called applied AI services. You can use them in AI Foundry. You can use them for .NET programs. There's a whole list of them below: speech recognition, language services, language detection. You can set it up to recognize PII, recognize specific objects, which can be useful for that application we saw at the very beginning of our model discussion, for detecting defective factory parts, and so on. This is Azure ML Studio. I'm actually not a data scientist, so I'm not going to demo it to you. It's actually one of the oldest Microsoft AI tools, dates back to, I believe, around 2014, and it can build traditional AI applications. What do we mean by that? Well, it's a playground where data scientists can experiment on data sets, large data sets. Canonical example is a healthcare data set with, say, 1 million rows in it, few thousand columns, and the data scientist wants to understand, of all those columns, which ones or which combinations of them are most likely to predict a hospital readmission. And that takes just a lot of work to look at the model, to perform experiments, and so forth. So in summary, Microsoft has carefully segmented their tools by persona. Some of them have some rough edges. Microsoft is actively and heavily investing in them per their developer-centric heritage. So please expect them to smooth out over time. Now, there's a couple of bets here that you should be aware of. One is that I think the obvious one is that more and more developers use Microsoft's tools. Obviously, Azure consumption across the entire spectrum of services, from data to tools to models and so on, will increase, which will increase their revenue. And more subtly, more and more will follow Microsoft's path, Microsoft's paradigm, really, to the AI native future of applications. Lastly, we'll cover hardware, an area that's receiving a ton of innovation and investment, not just from Microsoft, but from around the industry. So why do we need custom hardware? Well, essentially anything to accelerate and lessen that massive overhead of AI training. Any innovations that can make all those calculations, all those matrix multiplications, exponentiations faster and cheaper, well, such innovations will be well received, let's say. Now, we talked before about GPUs and how they naturally adapted to doing AI workloads. But now we're learning how to improve and customize those basic designs just for AI. For example, with respect to memory. The GPU that's in your workstation or in your laptop uses something called GDDR memory. And we've learned now that there's a better kind called HBM, high bandwidth memory, which actually stacks memory chips on top of one another, on top of the processors on the accelerator card. And that makes it faster for high dimensional matrix multiplications and a lot of other goodnesses. On the other hand, it's very expensive. However, HBM is kind of the thing for these new AI accelerator chips. Market leader here, the dominant one, no surprise, NVIDIA. But there are lots of others, including a whole bunch of startups that are doing these things as well. I haven't listed all of them or anywhere close to all of them. AMD is interesting. It has something called the Instinct Accelerator, which supports 192 gigs of HBM3, which is, I think, the market leader so far. And there actually are Azure VM types that support that. But in terms of Microsoft's own custom AI, well, custom AI accelerator, custom AI chip, they're actually a little behind. AWS has had its Trainium and Inferentia chips for training and inferencing, surprisingly, out for a while now. And Google has had its tensor processing unit, renamed Trillium. It's up to, I believe, its 6th generation, whereas Microsoft is just now coming up with its very first AI accelerator called the Maya 100. Some of the technical details, it's a 5 nanometer process. Like almost all of them, it's manufactured by the Taiwanese vendor TSMC. It's not currently available. Actually, not a whole lot is known about it. We're thinking it's probably likely only to be used by Microsoft's own workloads. maybe not now, or at least not until later, used for customer applications. And in some, it's at least equivalent to the state of the art that we saw on the previous slide, but not surpassing it. But the good news is Microsoft is not betting the farm on it. In fact, Microsoft has an agnostic approach to AI hardware. So I would expect that most AI workloads in Azure will continue to use NVIDIA GPUs for the near term. And let's not forget that just because you have hardware that you're done, you also have to have the software stack that supports it. And here again, NVIDIA has an advantage. They've been building API stacks for their stuff called CUDA for quite some time now, and it's well entrenched. So I would expect Microsoft to continue to hedge its bets as needed. No hardware relationship is monogamous. And if we're talking about hardware, I suppose we have to talk about the client as well. We'll just have one slide on this. Most people know that Microsoft at Ignited introduced something called the Copilot Plus PC. It's a brand for a new class of PC that's equipped with this thing called a neural processing unit. Essentially, it's a local AI accelerator. If you have an iPhone or Android phone that does biometric or facial recognition to help you log in, you're using an NPU. Interestingly, Microsoft has set the standards for Copilot PC very high. They say that the Copilot PC must support 40 TOPS, that is trillions of operations per second. And I just can't help but think of remembering in my youth that we measured computers by MIPS, millions of operations, and now we're up to trillions. In any event, the Intel Core Ultra i9s are only at 10 TOPS so far, so I think the mainstream hardware vendors, not counting the Snapdragon from Qualcomm, which does support this, but AMD and Intel have a ways to go. The killer app for this? Well, that's an interesting question. Is there a killer app for the NPU? And we don't know. There was an app that's, I think it's still in private or public preview called Recall. It takes and remembers a screenshot of your screen every few seconds. Why? Well, the idea is you can go and search for what was it you were doing the day before or yesterday at 3 o'clock in the afternoon. And it can decipher text that's embedded in the screenshot and so forth. It was very controversial when it was first announced for reasons that are fairly obvious. And it's still not even clear that even if they can get past all the privacy or snooping objections, that it really is going to be a killer app. Summary notes for all this. The drive to accelerate AI training and reduce the costs of it will drive the next era. There's some questions we have here. Can TSMC or the U.S. foundries subsidized by the CHIPS Act keep up? The economics, won't get into it, but they are complicated. Everybody is competing for these scarce resources. Microsoft, Google, AWS, IBM, Meta, Alibaba, probably many others as well. And consumers, you are too. They're all competing for the scarce resource of AI processors, AI-capable processors. So ultimately, Microsoft's agnostic strategy is probably pretty wise, probably is the right one. So let's now wrap up our presentation and talk about some of the issues, risks, speed bumps even, and possibilities, and the outlook for the future for Microsoft's AI strategy as we presented it. So the first question is will customers, that is, will you adopt Microsoft's AI vision? And for you, is it going to be evolutionary or revolutionary? And for that, let me invoke Barry's law of enterprise spend. I came up with this law, so I get to name it. I'm naming it after myself, and I'm copywriting it. Companies only spend money on A, making operations more efficient, which is kind of, okay, not as exciting, or on new business opportunities, new revenue opportunities. That's exciting. More money. Every single AI use case workload I have seen is about the former. It's about cutting 20% off of this business process, or reducing the workload on our workforce by 10%, or even reducing the workforce by 10 or 15%. Making our employees more productive, making our customer interactions faster. It's making our operations more efficient. Some of those lead into potentially new business opportunities, but they're not in and of themselves new innovation, new revenue generating opportunities. One question. And all of this will mean a massive re-engineering of your enterprise ecosystem. We talked about how you'll have to protect your entire enterprise data estate. There are whole new paradigms to learn, as we've seen. There are new skill sets. There are new skills to hire for, new career ladders even. Now, another potential speed bump, and I think we all recognize this, is the scale of investment required by everyone is huge. And the $1 or $10 or $100 trillion question is it even possible? We know that LLMs in and of themselves are expensive to train, they're expensive to run. And when we start adding new capabilities like reasoning and planning, we start building applications that are consisting of multiple LLMs. All that's going to dramatically increase consumption. It's going to dramatically increase costs. It's going to dramatically increase things like carbon footprint and so forth. Now, Satya says he's good for his 80 billion, which is targeting investment in data centers. And to be clear, that's well over 20% capex to revenue, which is substantially more than the US average of 8%. But Stargate is talking about $100 billion, not $100, but $100 billion investment straight away, and over time, $500 billion, which leads us to the inevitable question, can Microsoft or Stargate actually spend all this money? And how will they recoup their investment? To answer that question, we'll pick up on a comment that Satya made in one of his public appearances, and back up just a little bit and take a look at the current billing model for the cloud. Is incredibly complex. It's very difficult to understand all the nuances, all the synthetic or artificial billing units like resource units and so forth, which are combinations of various kinds of consumption, reservations, capacity, hybrid benefit, and so on, which makes it difficult, if not impossible, to predict costs in advance. According to Satya, the new kind of currency, the new sort of currency is tokens per dollar per watt, which if you think about it is if all applications become AI native, might be the right approach. Now, is it any more or less predictable? I don't know, but it is a new approach and it may be simpler. Now, another huge speed bump that's coming is, of course, regulation. Now, as with privacy and the GDPR, the European Commission was actually the first to introduce an AI regulation called the AI Act. And it's actually really a framework, and it categorizes AI by risk level. So any AI application that targets children is, by definition, forbidden. Applications that are built with AI that robotically examine resumes or college applications, for example, those have to be audited. Their training data has to be examined by humans every so often. Spam filters and applications that, for example, scan for defective parts on an assembly line, those are thought of as being minimal risk. Interestingly, the penalty for violation of the AI Act is 6% of revenue, even more than the GDPR at 4% of revenue. Now, lots of other countries are following suit. Some US states are following suit, but so far, there's been no legal precedent or case law yet. So we'll see that, and it's inevitable. So expect that there will be many regulations with which organizations will have to comply. Another question we should ask is Microsoft over-indexing on AI? Are they doing AI to the exclusion of things they should be working on? You know, the answer to every computing question is not AI. If a valve on a factory line is running hot, if a motor's not running correctly, turn it off. That's 2 or 3 lines of code. And yet, it feels like every development team at Microsoft is rewarded for implementing AI. Another even more important question is Microsoft ignoring other needs or opportunities? For example, an area that I'm very interested in, every factory, every plant, every power grid that I'm aware of needs an IoT upgrade. It's all critical infrastructure. And so at Ignite, Microsoft announced a very innovative product called Azure IoT Operations, which is a modern way of upgrading all the antiquated OPC and SCADA systems that are out there. But it landed with pretty much zero fanfare, which makes me wonder, is it really getting the investment that it needs? And is it really getting the investment that, frankly, the industry needs? And lastly, Microsoft, I think we're all aware, Microsoft gets applications. But the kind of less strong ones, really thinking about the overall enterprise, the enterprise ecosystem, the enterprise architecture. And let's face it, most large companies have hundreds or even thousands of enterprise applications. When I worked in Microsoft IT, we had about 2,000 applications or so, and that's not atypical. Getting them all to work together harmoniously and seamlessly, getting all the sand out of the gears as we move data from one to the other, without the need for complex integrations, without the need for complex ETLs, without the need for rolling data definitions updates every quarter, every month, and so forth, is a challenge. It'd be great if our applications all operated off a common definition of customer and product and so forth, but Microsoft has really not shown a whole lot of interest in helping us solve those kinds of problems. Finally, let's talk a little bit about DeepSeek and Stargate. Is everybody saying, is DeepSeek an existential threat to Microsoft? I don't think so. We all know by now what it is. It comes from Llama and Quen and maybe even rumored that OpenAI. It's open source, pretty cool. It's downloadable. You can run it on your desktop. I do. And frankly, I think it's just one more LLM that you can drop into AI Foundry's library, from which developers could pick and choose and use should they desire. Remember, Microsoft used to talk about embracing and spending. And guess what? I'm recording this on January 31st. 2 days ago, it was, in fact, included in the Azure AI Foundry library. Let's just remember that DeepSeek, at the end of the day, it's a model. Microsoft is a full stack AI tools, applications, and solutions company for the enterprise. Is Stargate an existential threat to Microsoft? Well, I don't know. I mean, $500 billion is that's some serious money. Microsoft is a technology partner, so will they be running Azure inside of Stargate? I don't know. We don't know what Stargate will be used for. Maybe all these complex multi-agent applications that we were talking about before that are going to gobble up CPU and GPU resources. Potentially, it does indeed threaten Satya's $80 billion pledge. We talked about this. Are there enough firms to build these things? Are there enough servers? Are there enough GPUs? We know there's going to be a scarce resource out there, so we'll see. So in closing, let me say, first of all, that Microsoft is one of the few companies that survives and even thrives through tech disruption. Remember the days of the GUI when Microsoft introduced Windows and the internet, and Microsoft was behind the cloud when Microsoft was behind AWS and so on. This is one of those periods. And Microsoft, I have every confidence, will thrive in a new AI native world. As we said, and this is probably the most important bullet in the entire presentation, Microsoft seeks to be a full stack AI tools, applications, and solutions company for the enterprise. My opinion, their vision of an AI native stack is indeed bold and compelling and cohesive and logical, even if it doesn't quite fit quite perfectly all together yet. And of course, it's also risky. Is this what the market really wants? When will they want it? How fast can they adopt it? And ultimately, the answer to the question, will Microsoft be successful? Well, it's up to you. It really is. So I have some final thoughts. We talked at the very beginning about the stack on the left and how that implies a whole new model for building applications. And I confess I find this both exciting and yet a little bit sad, and I'm even feeling a bit wistful about all this, because as a professional software developer for well over 40 years, kind of feels like my world is slowly evolving into something new. But maybe it's time that I hang up my coding spurs and go off and conquer whole new worlds. So if you made it this far, thank you very much for your time and for your attention. And I guess I can't say happy coding anymore, so I'll close with happy agenting, I guess. Thanks very much. Take care.